How do we measure code performance? Instead of timing seconds, which vary by hardware, we count fundamental operations as input sizes grow. Let's analyze a simple loop. Inside, we perform a constant time operation. Since the loop repeats exactly n times, the total operations scale linearly with n. What happens when we nest loops? Here, for every outer loop iteration, the inner loop also runs n times. This gives us n multiplied by n, or n squared operations. In a binary search, we divide the search space in half with each iteration. Instead of scaling linearly, the operations grow logarithmically, making it incredibly fast. Mathematically, we focus only on the fastest growing term and drop constants. This simplifies our counting into asymptotic big O expressions. Comparing these curves highlights why complexity matters. While linear and logarithmic scales handle massive inputs easily, quadratic curves explode rapidly.